Right, so today we're going to be looking at binomial expansion. So we're going to have a look, and what's already on the board here is a formula which you're given, and this is given in your formula book. So no matter what board you do at A level, this formula you get given. So a plus b to the n, and we'll explain what each bit of it means, but this is the stuff you need to know in advance of that. So you've got a plus b to the power of n, and a to the n, n1, an minus 1, b, and so on. And I'll explain what that all means, so don't worry about it. I'm just giving you what you already get given. So you have your formula book and you will have this. And what does this n1, n2 mean? It means n choose 1, n choose 2. And if you have a look at your calculators, so if you're doing A-level maths in the UK, I really recommend you have a class whiz calculator. It's a Casio calculator. And above the divide sign, so it's the button above the divide sign, you'll see it says NCR. In your formula book, you will also be given how it breaks down to look like this. So in case you don't remember or you haven't seen it before, what does factorial mean? So what does this n factorial mean? So all the n factorial is the number of ways of arranging n things in a line. But all you're doing, it's the same as n times n minus 1 times n minus 2, all the way till you get to 1. So for example, 10 factorial is 10 times 9 times 8 times 7 times 4 times 3 times 2 times 1. And again, you have a factorial button on your calculators. So it's below the x squared button, but I wouldn't worry about it. You tend not to use it that often. So the NCR button is the bit that's really important. So the first bit of this is we're just going to use the formula. So all the formula does is when we have something squared, so when we're opening a quadratic, super easy to open. We times them by each other. Cubic, we could even do that. Open the quadratic and multiply it again. But what if we had something much bigger? So say you had something to the power of 10 or the power of 20. That starts to become tricky. And that's where this formula helps. So if we take, so what we're going to do is we're going to take an example question. And literally, without knowing anything, how you use the formula and you plug the numbers in. So we're going to start with that and then work up to where it gets a bit trickier in A-level exams. So if, for example, we had 3x plus 1 to the power of 10. So all you're going to do is you've got this formula. You turn to it in your formula book and you match things up. So if I match up things, I can see my a is the same as 3x here. That's what I'm going to have as my a. My b is like the 1, and my n is the 10. So therefore, wherever I see an a, I'm going to put 3x. Wherever I see n, I'm going to put 10, and so on. Now, exams will never make you write out all the terms, because you'd be there for a while. What we're going to do is generally they ask you the first 4 terms. So the first 3 are given, and then hopefully you'll start to see the pattern. So your a is 3x. So I'm going to take my 3x, and it's I'm putting it all in a bracket. That's really important. And so we could do 3x to the power of 10. Then I could have n1, so 10, 1. And now you'll see why this is giving it to me backwards, because I'm saying I want it in descending order. If I wanted it in ascending order, it would be slightly different, but let's do our descending order first. So this would be 3x to the power of 9, because n minus 1, multiplied by b, which is 1. 10, 2, 3x to the power of 8, 1 squared. Now, hopefully you could do the 4th term, which would be 10, 3, 3x. Can you see this was n minus 2? Now we're going to do n minus 3. So 10 minus 3 to give you 7, and that would be 1 cubed. Okay, so that's going in descending order. So that's going from x to the 10, x to the 9, x to the 8, and so on. Now, typically, you may be asked to do in ascending order. So you want the first 4 terms going x, x squared, x cubed. Now, if that was the case, we're going to flip it. I'm going to flip what our a is and flip what our b is. So if I flip that round, I get 1 plus 3x to the 10. So it's exactly the same, but I flipped it round to make it easier to see. So now my a is 1, my b is 3x, and my n stays as 10. And this is the one that we're going to calculate out. So we're going to get a to the power of n, so 1 to the power of 10, and then 10, 1, 1 to the power of 9, 3x, and 3x on its own, 10 to the power of 2, I'm just going to erase this so we've got some space and I don't confuse it. Right, 10 to the power of 2, 1 to the power of n minus 2. So essentially what you're doing is you're doing this minus this. So you get 8. Then you're going to have 3x and it's all squared. That's the important thing. It's the whole of that b squared. And now following the pattern, we've got 10, 3, 1 to the 7, 3x cubed. And now we're going to plug that all into a calculator. So when we put that into a calculator, what we get is we're going to do, well, you shouldn't have to do 1 to the 10, it's just 1. And for 10, 1, in your calculator, that's 10C1. So 10C1 gives you 10, times 1 is 1, times 3 is 30. Here you're going to do 10C2, you don't need to times it by 1, but the important thing here, it's times 3 squared. So it's timesing it by 9. And when you stick that all in your calculator, get 405, and it's going to be x squared. And then we've got 10C3 times 1 times 3 cubed. And then we get 3240 x cubed. But it's remembering that everything's cubed. So that's everything, literally, you just literally have to plug them into your calculators. That's all you've got to do. You get given the formula, match it up. Typically, you'll be asked for descending order because you want to go x, x squared, x cubed. Ascending, make sure ascending order, if they ask for descending order, make sure you flip it. So it looks like what we had at the top. Okay, so now let's take something a little bit, maybe, what I'd also do, by the way, is also just do a ... That's just good practice. That shows that there are other terms, even though they only asked for the first 3. Okay, so what we're going to do now is, actually, let's do one more example and actually take numbers in both and have a fraction there, because that tends to be what confuses people and seems to stress students out. All right, I'm sure there's a much more efficient way to erase this, but we'll go to, I don't want to rewrite the formula, just being lazy. Okay, so say we had, actually let me find an exam question. So if we take a typical question, which has a fraction in it. Okay, so we've got one here. We've got 2 minus, so 2 minus 1 over 3x, so that's 2 minus 1 over 3x to the 7. And I want the first 3 terms in ascending order. So remember, this is going to be my a, the 2. Now here again, I've chosen this on purpose because we've got minus. So my b is minus a third x, and my n is 7. So now let's substitute everything in. And we're going to go slow, but you have the formula. This is not difficult. So this shouldn't be difficult. So you've got a, which is 2 to the power of 7 plus 7, 1, a, which was 2 to the power of n minus 1, so 7 minus 1 to give you 6. And then because we've got negative, it's b, the whole thing goes there. So it's minus a third. Plus, and I know when you've done a few of these, you start to think you can do them really quickly, but always just lay it out. The working gives you the marks. You might as well get the marks there. So we've got n minus 2, so 7 minus 2 to give us 5. And then we're going to have minus 1/3 all squared. So it's inside the bracket. Now remember, so whenever you see a negative squared, your brain's going, okay, I know this is going to end up being positive. And then plus ... to represent it goes on. Okay, now stick it into a calculator. Each term separately, don't try add anything up. So 2 to the power of 7, when you put that in a calculator, gives you 128. Then 7, 1, which is 7c choose 1, which is choose 1 is always just going to be the number. So 7c1 is always 7, doesn't matter. Times 2 to the power of 6 times by minus a third. And that gives you minus 448 over 3. Generally in pure maths, keep things as fractions unless they ask for it as a significance figures. And in applied maths, do them as decimals to 3 decimal places or 3 significant figures. Okay, so then we've got 7c2 times 2 to the power of 5. Now it's minus a third squared, and it's all in a bracket for a reason, because it's going to become positive. So we get plus 224 over 3. Sorry, I missed the x out in the working. There's x and there's x there. X squared. Right, so altogether, that's your final answer. So you substitute in, that should be quite straightforward. Now, the way this gets extended and the other questions you get asked is you tend to get asked for like a general term or one term of an expression. So the general term of an expression is if you've got a plus b to the n, the general term, so the third term or the fourth term or anything like that, if you want the power of x that you want, you've got to think which term will it be. So for example, if I had, if I had 2 plus x to the 10, and I know the power that I want is the third term. So if I tell you I want the power of x that I want is 3. So I want the x bit to be cubed. So I want this r number here to be 3. So that means I'm going to have 10, 3, 2 to the power of 7, x cubed, without having to go through and open it all out until you get to x cubed. So remember, the 2 powers will always add up to 10. All right, so let's take where this is useful. With cubed, you could have actually opened it out to cubed. So say you have 2x minus 1 to the 75, but you want the 50th power of x. God, I don't know what's happening there. So you want the 50th power of x. So we want the 50th for the x, but we want the x to be our b, right? Because we want the b to the 50. So I'm going to rewrite that as 1 minus 1 plus 2x to the 75. So then I'm going to get 75 and 50. I'm going to have minus 1. So because I know I want 2x to the 50, minus 1 to the 25, and 2x to the 50. And now if I was to open that out, I get the 50th term. So just think about your general term. If it's always going to be in terms of x, you want the x onto where the b is in order to use the formula easier. So say I had 7 minus x to the 12, and I wanted the 7th power of x. What I'm going to have there is I'm going to have 12 7. So whatever power of x is the number on the bottom. And I'm going to have 7 to the power of 12 minus 7, which is 5. And then I'm going to have minus x to the 7, which will give me the 7th power. So that's something that doesn't necessarily always get taught in an obvious way, but comes up in an exam. And I think my students eventually get there, but it's quite good to think of it just as a general term. So let's take an example of an exam question where you would use this. All right, so we've got in an expansion of, so we've got 1 plus ax to the 10, and it tells you the coefficient just means the bit in front of, the coefficient of x cubed is double the coefficient of x squared. Of x squared, find a. Okay, so remember, we're going to look for the x squared term and the x cubed term. So the good thing is the x is in where the b would be. So your x squared term is going to be 10 to 1 to the power of 8, and then ax, which is the whole of your b, squared. So you're going to put that in your calculator. You're going to do 10c2. So you're going to have 10c2 in your calculator. So remember, the C button is above the divide. It might not be in yours if you have a different one, and you'll get 45. And then you're going to do a squared x squared, because it's everything in that bracket. So now let's think of the x cubed term. So the x cubed term, we're going to have 10, 3, 1 to the power of 7, and then ax cubed. So 10c3, I'm going to stick that in my calculator, and I get 120. And then I've got a cubed, x cubed. And I just care now about the coefficient. So the bit that's the coefficient of x squared is the bit in front, and the bit that's the coefficient of x cubed is the bit in front. So I know that the coefficient of x cubed, which is 120a cubed, is the same as double, is 2 times 45a squared. Okay, so what can we do? Well, that's 90a squared, 120a cubed. Now, your instinct is to cancel out the a's. Don't cancel out the a's. You can cancel down the numbers, but don't cancel down the a's. So I'm going to move everything to one side. So I've got 120a cubed minus 90a squared equals 0. Simplify that to give me 4a cubed minus 3a squared equals 0. I can take a squared outside a bracket and I'll get 4a minus 3. So my answer is a equals 0 or a equals 3/4. Now the bit I missed in the question, it told us to begin with that a is non-zero. So it says a is non-zero. So, and also it would make sense for a not to be 0, but you can't just assume that it disappears. You've got to move everything to one side just in case 0 is an option. And then at this point you say a is non-zero, therefore a equals 3/4. And that would have got you the marks in that question. So let's take one with an expansion. So there's only one little bit left of this topic, which is when you have to do an expansion to estimate. So we'll take, so this is from 2015. There we go. So it says find the first 4 terms of the binomial expansion. So we've got 1 plus x over 4 to the power of 8. So we want the first 4 terms, and then that's part A. So part A says find the first 4 terms. First 4 terms. And part B says use this to estimate 1.025 to the power of 8. Okay, so we need to do part A to be able to do part B. So for part A, our A is 1 and our B is x over 4. So 1 plus x over 4 to the 8 is going to be 1 to the 8, so that's the A to the power of n, plus 8, 1 to the power of 7. And obviously you don't have to write 1 to the 7 when you're doing your working in the exam. I know you know that 1 to the power of anything is 1, but we'll just put it here for like, to make sure you follow everything. And then you've got 8, 2, 1 to the power of 6, x over 4 all squared, plus 8, 3, 1 to the power of, oh, I didn't mean to put a bracket there anyway, x over 4 cubed. Okay, so in my calculator, well, we don't need to do that, it's just 1. And then I'm going to do 8c1, which is 8, times by a quarter, because that's x over 4 is the same as a quarter x. So that's going to give me 2x. Then I've got 8c2 times by 1 times by a quarter squared, so 1 over 16. And that gives you 7 over 4, and remember that's x squared. And then you've got 8c3 times by a quarter cubed, which gives you 7 over 8 x cubed. We're going to put our dots in to show that it's further. So that's part A. Part B, we now compare 1.025 to 1 plus x over 4. And so when we compare it, we can find a value for x. So we're going to do 1.025 equals 1 plus x over 4. So this gives you x over 4 must be the same as 0.025. So therefore x is the same as 0.1. And so what we can do is we sub in 0.1 into here. And the reason that we can use this as an estimate is as you square a decimal, it gets smaller and smaller and smaller and smaller and smaller. So 0.1 cubed, 0.1 to the 4, is getting so small that we don't need to worry about it when we're expanding because it gets increasingly smaller. So we'll have 1 plus 2, and you just stick that into your calculator, 7 over 4, 0.1 squared, 7 over 8, 0.1 cubed. And you get 1.2184 to 4 decimal places. Now in an exam, I would always check. So plug into your calculator 1.025 to the power of 8, and you should get something around what your expansion is. And you get the exact value and you can compare it. So that's binomial expansion. So that's one of the topics in, this is the AS bit, in AS maths. It does come up, it's not difficult, but you have to be really careful. And because it takes a while, because you've got to take each individual term, it's usually worth quite a few marks. So I hope that's useful. If you missed any of it, and you know, it should be saved on YouTube, you can go watch it there. And if you've got any questions, let me know. And I hope that was